Hello friends, grab your coffee, grab your cookie, and please do not dip either one into an acid bath, because today we are talking about electroplating exhaust. These are the fumes that rise from those mysterious tanks where metal parts get dipped, coated, polished, cleaned, brightened, and sometimes even improved like they are at a spa for industrial parts. My name is Michael Klepik, and for 15 years I have been cleaning the air that comes out of electroplating lines. Today I will explain in simple language what these fumes are and how we safely get rid of them. What electroplating exhaust really is. Electroplating exhaust is not just steam. It is a complex mix of chemical aerosols created when metal parts are submerged into chemical baths at elevated temperatures. Depending on the type of plating, the exhaust may contain, first, acid mists from sulfuric acid, hydrochloric acid, nitric acid, or chromic acid. Second, heavy metal particles such as nickel, chromium, zinc, copper, and cadmium in aerosol form. Third, hydrogen gas and oxygen gas released during the electrochemical reaction. Fourth, organic solvents used in degreasing or brightening solutions. Fifth, alkaline aerosols created in cleaning and stripping baths. The key thing to understand is this: electroplating exhaust is almost always corrosive and in many cases toxic. This is why these systems require very specific types of air handling equipment. Where these fumes appear in electroplating lines. Electroplating facilities often include a long sequence of tanks. Here are the most common sources of fumes. First, acid pickling tanks for cleaning metal surfaces. Second, nickel or chrome plating baths at elevated temperatures. Third, alkaline degreasing and stripping tanks. Fourth, anodizing baths for aluminum. Fifth, heated rinse tanks where hot water evaporates quickly. Sixth, chemical conversion coating baths such as zinc phosphate. Any process where the bath is warm, bubbling, or electrically active produces visible and invisible fumes. And when the surface area of the liquid is large, the emissions increase dramatically. Why electroplating exhaust is dangerous? These emissions are hazardous for several reasons. First, acid mists damage the lungs, eyes, and skin. Second, heavy metal aerosols accumulate in the body and are toxic over time. Third, hydrogen gas can accumulate and create an explosive atmosphere if the ventilation is poor. Fourth, the corrosive nature of fumes destroys metal ductwork, fans, and electrical equipment. Fifth, in chrome plating, hexavalent chromium aerosols are highly regulated and require very high scrubbing efficiency. Simply put, this is not ordinary steam. Electroplating exhaust must be contained, captured, and treated correctly, or it becomes a danger to both people and equipment. How I capture fumes from electroplating tanks. Capturing these fumes starts at the source, the tank. I typically use one of three capture methods. First, a slotted side draft hood along the entire length of the tank. Second, a canopy hood placed above the tank for high temperature operations. Third, a lip exhaust built directly into the tank rim for the highest efficiency. The goal is to pull the fumes sideways or upward before they escape into the room. The required airflow usually ranges from 200 to 500 cubic feet per minute for each square foot of tank opening, depending on the chemical process and temperature. Proper capture design saves energy and improves scrubbing efficiency dramatically. How we treat these fumes: wet scrubbers. For electroplating fumes, dry filtration does not work. These contaminants must be washed, neutralized, and removed using wet scrubbers. Torch Air builds several types of scrubbers that I use in these environments. First, a packed bed scrubber, ideal for removing acid gases and metal aerosols. Second, a horizontal scrubber for long tank lines with limited vertical space. Third, a multi-stage scrubber when the exhaust contains both acids and fine particulates. Fourth, a venturi stage if the exhaust includes solid particles or mist that must be mechanically captured. In most plating lines, a packed bed scrubber is the heart of the system. It works by spraying neutralizing liquid downward through a bed of specialized packing material while air moves upward. This creates intense contact between the air and the liquid, which removes acids, metals, and fumes. For chrome plating, I often add a mist eliminator stage to meet the strict efficiency requirements for hexavalent chromium. What makes electroplating scrubbers different from standard scrubbers? Electroplating exhaust requires specialized materials. Standard mild steel fans, ducts, and housings will not survive. Here is what I use. First, polypropylene or fiberglass reinforced plastic for the scrubber body. Second, polypropylene ducts for the entire air path. Third, non-metallic fans that cannot corrode from acid fumes. Fourth, corrosion-resistant spray nozzles and pumps. Fifth, high-efficiency mist eliminators designed for small droplets. If you try to use regular materials, the system will corrode, leak, and fail, sometimes in less than a year. The most common mistakes I see. Let me list the mistakes I encounter in many electroplating shops. First, using metal ductwork that corrodes within months. Second, placing the hood too far from the tank opening, reducing capture efficiency. Third, undersized scrubbers that cannot neutralize all contaminants. Fourth, not maintaining the pH and concentration of the scrubbing solution. Fifth, forgetting that chrome plating requires additional mist elimination stages. Sixth, not providing enough airflow to remove hydrogen gas safely. Any of these mistakes can create serious safety hazards. What I always do on electroplating projects, here is my standard approach. First, I measure each tank's surface area and temperature to calculate exact airflow. Second, I choose the correct capture hood based on the chemical process. Third, I design the scrubber using corrosion-resistant materials only. Fourth, I size the packed bed height based on the contaminant loading. Fifth, I ensure the fan and ductwork are fully acid-resistant. Sixth, I add a mist eliminator stage if needed for metals or chrome. Seventh, I make sure the scrubbing liquid can be monitored and adjusted easily. These steps create a system that works safely, reliably, and for many years. Electroplating exhaust is one of the most chemically aggressive types of industrial air pollution. It contains acid mists, metal aerosols, and gases that are dangerous for both people and equipment. But with proper capture design, corrosion-resistant materials, and a well-designed wet scrubber, these fumes can be controlled completely and effectively. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, a plating bath may make your parts shiny, but the exhaust must be handled with real engineering. See you in the next video.